All right, in this lesson, we're going to talk about probability and how we can use it to make fair decisions. The first essential question says, how can you use probability to help you make a fair decision? Well, we can set it up where probability will offer a method for representing a population in a random way. Most of this is intuitive, meaning I think you know the answer. You've just got to stop and you've got to think about what you know about probability and use it to make a decision that's fair for all parties involved. So let's look at this first example about we're sharing a veggie supreme pizza with friends. There's one slice left and you and just one other person both want it. Both of you already had 2 slices. What is a fair way to solve this problem? Well, there's a lot of different answers you could use here, but if you're anything like me, a lot of times if you have a brother or sister and you want to do this fairly, a parent will say, one of you cuts the pizza into 2 equal slices, and the other one gets to choose. So that's one possibility. And that's only if we want to make it equal and both of us get some. But here in example B, it says, suppose instead you decide that one of you will get the entire slice of pizza rather than the whole thing. So we want to determine using probability a way that both of you get a fair chance. So there's, as you can see, 4 different experiments or options here, and we want to determine, are these fair? So if you flip a coin, there's obviously 2 sides to a coin. There's heads and there's tails. One of your heads, one of your tails. This is a fair experiment because you have a 50-50 shot. Neither one of you are giving an unfair advantage. If you roll a standard die, one result is a 1, 3, and a 5. Your friend gets the last slice. For you, it could be, if you roll a standard die, you get a 2, 4, 6. Both of you have a 3 out of 6 or 1/2 chance of winning the standard die rolling game. Rock, paper, scissors, you can either win or you can lose. Again, that's fair because even though there's 3 different things you can be in paper, rock, scissors, you have a 50-50 chance of winning this game, which comes down to luck. And finally, drawing straws. The longest straw usually wins. So you can draw the long straw or the short straw. But again, it's a game of chance, and it's considered fair because there's a 50-50 shot there. So this last example gives maybe you an option to make an unfair experiment. So that last example where one of you cut it and the other one got to choose the piece, what if the option was given that I will cut the last piece and I'll choose which piece you get? Why is this method unfair? Think for a second and write down your answer. So hopefully you came up with this, and especially if you have a brother or sister, or even just a friend that you've done this with before, you would purposely cut one of the pieces much larger, and then you would just choose the large piece for yourself. So that's an example of an unfair experiment there. So let's go to this page, and let's decide whether each method is fair or unfair, and then determine the probability of each, and using that to show why it's fair or unfair. So this first one says, roll a standard die. Mary wins if the result is less than 3. So that means Mary, probability of winning is 2 out of 6, which reduces to 1/3. There's 2 numbers less than 6. There's 6 total outcomes. Riley, on the other hand, wins if the result is greater than 3. Well, 4, 5, and 6. So she actually has a 3 out of 6 chance or 1 out of 2 chance of winning. So this would be an unfair method. And that's, of course, because Riley has a better than 50% chance of winning than Mary does. A way to make it fair would be, okay, how about that number 3? If Mary rolls a 1, 2, or 3, she wins. Number 4, you draw a card from a standard deck. Standard deck has 52 cards. Mary wins if the card is red. Half the cards are red, so that's 26 out of 52. Which reduces to 1/2. Riley wins if the card is black. Half the cards are red. Half the cards are black. It's a random experiment. So they both have a 50% chance of winning. So this is a fair method. Flip a coin. This one's obviously, both of them have a 1 out of 2 chance of winning. So that's considered fair. Pause the video, try 6, 7, and 8. So number 6 is considered unfair. We can't really calculate the probabilities here because we're not given any hard data, but the person who jumps higher obviously has a better chance of winning. And remember, the directions say up here we want to choose a winner based on whether each person has an equal chance of winning. Number 7 is considered fair. Roll a standard die, or half the numbers are even, half the numbers are odd. So both of those probabilities reduce to 1/2. So that is a fair experiment. And then, of course, this last one should be considered unfair. And let's see who it's unfair for. Mary wins if the stone is black. Well, 5 out of 9 of the stones are black. That's greater than a 50% chance Mary wins. So I'm guessing Riley is the person that loses out on this. Riley wins if the stone is white. Yep. So she has a less than 50% chance of winning. So that's why this one's unfair.